Hi, welcome to today's session about acid, base, and salt. And this session is presented to you Dr. Sridhar Gaur Orelli. And here is the summary of the acid, base, and salt lecture. And this is about the summary of the topic, and it concluded as that the pH is less than 7 for the acid material. It neutralizes bases. It forms H plus ions in solution. It reacts with the most metals to form hydrogen gas. It is a good conductor of electricity. So these are the above the summary points of the acid. Similarly, the from the chapter, the summary of base is pH is greater than 7. It feels slippery nature. It dissolves fats and oils. Usually forms OH minus ions in solution. Similarly, it neutralizes acids. And coming to the salt summary, a salt is a neutral substance produced from the reaction of an acid and a base. It is composed of negative ion of an acid and the positive ion of base. One of the product of neutralization reaction. It is one of the product of neutralization of reaction. Example, when potassium is reacted with chlorine, it will be formed potassium chloride. When magnesium is reacted with sulfate, it will be formed magnesium sulfate. So these are some of the figures related to the H of neutralization for the salt. Then some of the test experiments. Test for evolution of carbon dioxide gas. Carbon dioxide turns lime water into milky. What is that one? Carbon dioxide turns lime water into milky when passed through it. This is the characteristic test for carbon dioxide gas. The carbon dioxide turns lime water into milky. This is called as carbon test, carbon dioxide gas test. We have an equation here. Calcium hydroxide when passed through when carbon dioxide passed through the calcium hydroxide, that changed into the white color of calcium hydroxide changed into calcium carbonate, and which turn into milky color. Similarly, we have another test, that is about the test for hydrogen gas. The gas evolved after a reaction of acid with metal can be tested by bringing a lighted candle near it. If the gas booms with a pop-up sound, then it confirms the evolution of the hydrogen gas. So here the lighted candle must show an activity of bounce with pop-up sound. Then it will be defined as the hydrogen gas. Burning with the pop-up sound is the characteristic test for the hydrogen gas. We also have some summary about what is weak acid, what is weak base. So here the acid weak and strong, the base weak and strong. It is characterized on the basis of the ionized. What is that one? Ionized. On the basis of ionized property, we classify the acidic materials and basic material. Means acid materials are called acidic material. Base materials are called basic material. So here, what is on the basis of ionized? What is weak acid? Weak acid do not ionize completely. Those acid material which do not completely ionize, they will be called as weak acids. For example, acetic acid, boric acid, nitrous acid, phosphoric acid, these are the weak acids. Coming to strong acid. Strong acid ionize completely. Ionize means they need to give either H plus or OH minus ions. If you are checking that one, acidic material, there must be produce H plus ions. This means ionize. So strong acids ionize completely. What are examples of the strong acids? The examples of the strong acid is sorry, hydrochloric, nitric acid, sulfuric acid. And few of the examples of the acidic materials. The common acids are HCl, that means hydrochloric acid. It is present in the human stomach, our stomach. H2SO4, sulfuric acid. It is used in cannabis. Nitric acid. It is used in explosive materials. Acetic acid, it is used in vinegar as a cooking material for the taste of the food. Carbonic acid used in drinking sodas like soda, soft drinks. And phosphoric acid, it is used in flavorings, that is food taste flavoring materials. We are using this acetic phosphoric acid. What are the physical properties of the bases? Let's see here the physical properties of bases. We need to consider here they are the bitter taste. Strong bases are corrosive, and aqueous solutions of bases contain hydroxide ion, that means OH minus, that turn the red litmus into blue form. That turns red litmus to blue. And this is about the few of the examples of the basic material, that is sodium hydroxide, ammonium hydroxide, calcium hydroxide. So this is about the basic material. So here a reaction of base with the oxides of non-metals. So let's see reaction of base with oxides of non-metals. Non-metal oxides are the acidic in nature. For example, carbon dioxide is a non-metal oxide. When carbon dioxide is dissolved in water, it produces carbonic acid. Therefore, when a base reacts with a non-metal oxide, both neutralize each other, resulting respective salt and water will be formed. Here you can see when bases react with the non-metal oxide, it will be formed salt and water. You can see here base is what? Here carbon dioxide is a non-metallic material. You can take base material sodium hydroxide. So here, so NaOH is a base material and carbon dioxide, it is a non-metallic material. Then what it will be formed? It will be formed salt along with water. So this is about the reaction of the bases with the non-metals. So you can see we have another example. We have the 2 moles of the sodium hydroxide, 2 NaOH, which is in liquid status, that is aqueous, plus carbon dioxide, which is the gas. Then what you have, which it will be formed the sodium hydroxide. When it is react with carbon dioxide, it is formed sodium carbonate along with the water. You can see here sodium hydroxide 2 NaOH plus CO2 gives rise Na2CO3 plus H2O. So sodium hydroxide, it is a base, and the base is reacted with non-metal oxide, that is carbon dioxide. Then it gives sodium carbonate along with the water. Then what is weak base? So here the basic material which not completely ionized is called as the weak base. Here the example is ammonia, magnesium oxide. Similarly, strong base which completely ionized, a basic material which completely ionized is nothing but base material. Strong base material, the example is sodium hydroxide, barium hydroxide, calcium hydroxide. Then Based on this one, we evaluated a word, that is, we concluded a word is that the strength of the acid and base. We have this is one more definition about the strong and weak acid, strong and weak base. Let's see here. Acid that give rise to more hydronium ion or more hydrogen ions are said to be strong acid. Remember here we have another definition about the strong acid, strong base, strong acid, strong base, weak acid, weak base. Let's see here we have what is that another definition. Acids that gives rise to more hydronium ions, that is H3O plus. Hydronium means what? H3O plus. Acid that give rise to more hydronium ions or hydrogen ions are said to be strong acids. You come to here in the bases that give rise to more hydroxide ions. What is hydroxide ion? OH minus. So here bases that give rise to more hydroxide ions are said to be strong bases. And similarly, what is weak acid base? Acids that give rise to less hydronium ions or hydrogen ions are said to be weak acids. Now here, bases that give rise to less hydroxide ions are said to be bases. So here, which give more hydronium ions, that is strong acid, which gives less hydronium acids, the hydronium ions, that is weak acid. Similarly, which give more hydroxide ions is strong base. Similarly, which gives less hydroxide ions is called weak base. Then what are the common bases? The common bases we can see here, this is we found in our regular life, sorry, in our daily life, that is about the sodium hydroxide in the form of soaps, drain cleaners. Magnesium hydroxide, it is antacids. That means about the you are using when you took excess of food, the food is not digested and we feeling uncomfortable, that time we are using that is working as a antacid. Aluminum hydroxide, it is also antacid and deodorant. Ammonium hydroxide, it's used in ammonia. These are some of the figures which we are using in our household. Then according to Arrhenius, what is acid, what is base? In a water which produce H plus ions, that means in a water which producing hydrogen ions is called acid. In a water which producing, this is hydrogen, this is hydroxide. In a water which producing hydroxide ion is called as the base. According to Arrhenius, which producing hydrogen ions is called acid, which producing hydroxide ion is called base. Let's see, we have a few of the chemical properties or reactions of acid and base with metals. Let's see here. Acid gives hydrogen gas along with the respective salt when they react with a metal. What is that one? When acid is reactive with a metal, it gives hydrogen gas along with the formation of salt. Let's see here. Metal plus acid gives rise salt plus hydrogen. For example, hydrogen gas and zinc. Which one? Hydrogen gas and zinc chloride are formed when hydrochloric acid react with the zinc metal. So you can see here that is reaction of acid with the metals. When acid plus metal react, they gives rise salt plus hydrogen gas. You can see acid is HCl, metal is zinc, that is it will be formed zinc chloride is a salt, hydrogen gas. That means 2 moles of HCl is react with 1 mole of Zn, then it will be formed Zn chloride, means zinc chloride plus H2. Similarly, base sodium hydroxide, that means 2 moles of sodium hydroxide is react with the 2 NaOH plus Zn, it will be formed Na2 ZnO2 plus H2. Here that means when sodium hydroxide base is react with the metal, it will be formed sodium zincate, which is nothing but salt along with the hydrogen gas. That means when acid and base react with the metals, they will be released or they will be produce hydrogen gas. That is the conclusion of that reaction. Similarly, we have another thing, acids generating ions. You can see here when nitric acid, whenever it is dissolved in water, it producing H3O plus ions. This is hydronium ion. That means it is producing hydronium ion. A reaction of acid with the metal carbonate and metal hydrogen carbonates. Acids give carbon dioxide gas and respective salt along with the water when they react with the metal carbonates. You can see here metal carbonate is react with the acid, then what it will give when metal carbonate is react with the acid, it forms salt and carbon dioxide water. Let's see here, sodium carbonate is a metal salt. What is that one? It is a metal carbonate. The metal carbonate it react with the HCl. So NH2CO3, it is sodium carbonate. It is a metal carbonate. It is react with the acid. Then what it forms? It forms that sodium chloride, that means salt, H2O, that is water, CO2 gas. So this is about the reaction of the metal carbonate with the acidic material. Similarly, when you check the sodium metal carbonate, that means hydrogen carbonate, it will be formed, that is NaHCO3 plus HCl, NaCl, H2O, CO2. So from the above two equation, we conclude that one, acid react with the metal carbonates, acid react with the metal hydrogen carbonates. In both the cases, it will be give us salt, carbon dioxide and water. You can see here, one is a metal carbonate, the other one is metal hydrogen carbonate. This is metal carbonate. What is this one? This is metal carbonate, metal hydrogen carbonate. This is metal carbonate. Then it and acid, metal carbonate and acid gives rise sodium chloride, water, CO2 gas, CO2. Similarly, when the metal hydrogen gas, when it is react with the hydrochloric acid, it will be formed some NaCl, H2O, CO2. So in both the cases, it is producing CO2 salt along with the water. So here a few of the examples like this, limestone, chalk, marble are different from the calcium carbonate. Reaction between acids and bases. What is happening when acid is react with the base? When acid is react with the base, it will be formed sodium chloride and water. Let's see here, sodium hydroxide plus HCl. Sodium hydroxide is a base, HCl is an acid. So sodium hydroxide base, whenever they are interacted, they will be formed sodium chloride plus water. This reaction between acid and base gives rise a salt and water. This is known as neutralization reaction. What is neutralization reaction? Neutralization is nothing but when acid and base are reacted, they will be formed salt and water. You can see from this figure, acid and bases both are reacting together. When they are reacting together, they will be formed salt and water. Salt and water they are forming. And reaction with the metallic oxides. In this reaction, metallic oxide react with the acid to give salt and water. Similar, same thing. When metallic oxides react with the acid, it will be formed salt and water. When metallic oxides are said to be why? That means what? Here you can say that one from previous concept. See, acid base reacting means salt water is forming. Similar this reaction also. When metal oxide react with the acid, it forms salt and water. Now we can conclude here metal oxide is working as a basic oxide. A reaction of a non-metallic oxide with the base. What is happening when non-metallic oxide is react with the base? In this reaction, non-metallic oxide react with a base to give salt and water. Now you can see here salt and water. It is just like a neutralization. Is it right? Now we can say that on here, non-metallic oxides are said to be acidic. Remember here, non-metallic oxides are said to be acidic oxides. Metallic oxides are said to be basic oxides. Dilution of acid and base. The concentration of hydrogen ion in an acid and hydroxide ion in a base, hydroxide ion of a base per unit value, sorry, it's not in a of a base, per unit volume shows that concentration of acid or base. By mixing of acid to the water, the concentration of hydrogen ion per unit volume is decreasing as usual. So here for the water, for certain amount of water, if you add little amount of the concentration of the either acid or base, then the concentration of the acid or base, whenever it is added to the water, it will be decreasing, and this is called as the dilution. This is called a dilution of, if your acid is adding, that is dilution. If the base is adding, the dilution of base. Here we have that one. Addition of base. Sorry, this is you can go further. By addition of base to water, the concentration of hydroxide ion per unit volume decreases. This process of addition of acid or base to the water is called dilution, and the acid or base is called diluted. Now you can say that one from these two concepts here. By mixing of acid to water, the concentration of hydrogen ion per unit volume is decreasing. Remember, by mixing of acid to water, the concentration of hydrogen ion per unit volume decreases. Similarly, by addition of base to water, the concentration of hydroxide ion per unit volume decreases. This process of addition of acid or base to water is called dilution. The acid or base is called diluted. The dilution of acid or base is exothermic. What is that one? Exothermic. That means heat is releasing. And few more reactions about this one. Acid and base in a solution. When hydrochloric acid is react with the H2O, that means water, it will be form H3O plus ions and releasing chlorine here. More hydronium ions, more acidic. Similarly, when sodium hydroxide it dissolve in water, it will be formed Na plus OH. That means it will be releasing more hydroxide ions. That means it is more stable. Acids react with the water to give hydronium ions or H plus ions in water. Bases react with, what is the conclusion? Bases react with water to give hydroxide ions. Bases which are soluble in water are called alkalis. Bases which are soluble in water are called alkalis. The reaction with acid or base with water is highly exothermic, as we discussed previously. This is our each of neutralization concept. So here we are adding the acid to the water, or base are adding to the water. So when base or acid is adding to the water, it is going to be diluted, and this process is releasing some amount of energy, and this will be called as exothermic. Let we are moving to another one, that is about the pH scale. In a scale, this scale used to measure hydrogen ion concentration in a solution. What is that one? Hydrogen ion concentration in a solution. The P in the pH stands for potential. So here in the pH, P means potential. What is that one? Potential. It is a German meaning. The meaning is power. It is a German word, and the German word meaning is what? Power. Higher the hydronium ion concentration, low is the pH value. Now you can see here hydronium. If H3O plus ion is high, then pH value is low. This is the relation between the pH and the hydronium ion. Here acid materials are, we have it is thus pH is calibrated into 14 divisions, it will be considered 1 to 0, 1 to 6 will be called as the acidic material, 7 is the neutral material. Similarly, 8 to 14 is a basic material or alkaline material. Here, pH paper changes colors to indicate the specific. So we have the pH paper. The pH paper changes colors to indicate the specific pH value of a material. So it is about the pH scale. So this pH scale you can see here from 0 to 6 or 1 to 6, you can see that one: lemon juice, wine, and rain. These are about the acidic character. That's why it's shown before the seventh number. Seventh is a neutral state. 7.5 baking soda, that human blood, baking soda, and detergent and bleach. These all belongs to the basic materials, and it will be start from 7 to 7.5. It's about the human blood. Our blood is a basic neutral material, and baking soda, that is about the 8.5. So here this is about the one the same pH paper, and it will be, you can see here 1 2 3 4 5 6 7. So 1 2 3 it is a strong, and for 5 6 it is a weak acid. 8 9 10 it is a strong, sorry, it's a weak base, and 12 13 14 it's about the strong base. And here you can see exactly the seventh one is a neutral. pH of common substances. In our daily life, we will see some of the components, some of the elements, and that will be what? You can see here HCl is hydrochloric acid, gastric juice it is acid, lemon juice it is acid, vinegar it is acid, carbonated, that means in drinking we are using soda, that is beverages, that is acid, oranges acid, apple juice is acid, tomato it is acid, coffee it is also acid, bread, soil it is also acid, potato it is also acid, urine it is also acid, milk, the drinking one, it is also acid. Coming to 7, water is a pure form. This is about the pure form of the water is a neutral. Drinking water is 70.2, blood 7.4, detergent 8, sea water is 8.5, milk of magnesia it is more than 10, ammonia 11, bleach 12. This is about the few of the pH, few of the substances pH value. H neutral position, H plus ions are equal to OH minus ions. Importance of pH in our daily life or our everyday life. Our body works within the pH level to 7 to 7.5. When pH of rainwater is less than, rain is less than 5.6, it is called acid rain. So what is that one? What is acid rain? When pH of rain is less than 5.6, it is called acid rain. Our stomach is producing hydrochloric acid, which helps in digestion without harming our stomach. So here in a human body, the food is digested because of the hydrochloric acid. The hydrochloric acid is digesting the food without harming our stomach. In a case of indigestion, our stomach producing more acid, and it causes pain and irritation. To get rid of this, we use bases called antacids. These antacids neutralize the excess of acid. As we discussed earlier, that people nowadays people are buying the enos, they are drinking the eno to avoid this issue. When they are taking excess of food, because of excess of food, the acid is more acid is producing to, and because of this more production of acid, they get some pain and irritation, uncomfortable. To get rid of this issue, they are using enos. Eno is a antacid. Magnesium hydroxide, it is also called malcolm. Magnesia is a mild base. Tooth decay starts when the mouth of pH is lower than 5.5. So nowadays people are suffering with the tooth decay. The tooth decay is formed because of the lower of the pH that is less than 5.5. Tooth enamel is made up of calcium phosphate, which is the hardest substance in our body. That's why doctors suggested to you when you go to the dentist suggested to you use the base type of the paste. Bee sting leaves an antacid with which causes pain and irritation. Using mild base like baking soda and will give the relief. So this case we might be experienced. Bee stings leaves an acid which causes pain. So when the bees stings leaves an acid which causes pain and irritation, using a baking soda we can get the relief. Stinging air of nettle leaves the inject methanic acid causing the burning pain. Stinging air of nettle leaves injects methanic acid causing the burning pain. So a few of the things of acid and acidic material, it is a vinegar. Citric acid you can see in the lemon, orange. Tartaric acid we can find in tamarind and grapes. Ascorbic acid, people are using this is those who are suffer with the cough. The doctor is suggesting this one. All citrus fruits. Lactic acid, milk and yogurt. Malic acid, apples and pears. Then what is neutralization reaction? We already finished this one. A neutralization reaction is the reaction of an acid with a base to produce salt and water. Example, H2SO4. Sulfuric acid is reacting with the sodium hydroxide to form NaHSO4 plus H2O. Here acid and base are reacting and they will be formed salt along with the water. This is called as heat of neutralization. What are salts? A salt is an ionic product compound that forms from positive ion from a base and negative ion from an acid. So you can see H plus Cl minus. HCl is a hydrochloric acid, it is an acid. So the hydroxide is a base. When these two are mixing together, it will be formed water and sodium chloride. Here sodium chloride is called as salt. Sodium chloride, what is sodium chloride? It is formed after the reaction between the hydrochloric acid, it is a strong acid, sodium hydroxide, it is a strong base. Sodium chloride. Sodium chloride is also known as common or table salt. It is formed after the reaction between sodium hydroxide and hydrochloric acid. It is a neutral salt. The pH value of sodium chloride is about the 7. Sodium chloride is used to enhance the taste of food. Sodium chloride is used in the manufacturing of many chemicals. As we discuss here, when the sodium chloride is formed because of the sodium hydroxide and HCl. This is a heat of neutralization or neutralization reaction. In the neutralization reaction, the sodium chloride is formed. Sodium chloride is also known as table salt or common salt. It is used for the tasting of food. It is used in many chemicals. You can see the figure here. Sodium hydroxide, when it is react with the hydrochloric acid, it will be formed NaCl plus H2O. This is about the neutralization reaction. How are the salts are formed? How the salts are formed? Strong acid is react with strong base to form the neutral salt pH of 7. Then strong acid weak base will be formed. Strong acid, that means you will get the strong acid weak base, that means acidic salt, the pH is less than 7. Strong base weak acid, that we will get basic salt, the pH is more than 7. So here sodium hydroxide. What is sodium hydroxide? The another salt is about the sodium hydroxide. When electricity is passed through the aqueous solution of sodium chloride, that will be called as the sodium chloride solution is called as the brine solution. When electricity is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide, and this process is called as the chloroalkali process. Remember here, when electricity is passed through an aqueous solution of sodium chloride, that means brine solution, it decomposes, that means separated, it decomposes to form sodium hydroxide. This process is called chloroalkali process because of the products formed chloro for the chlorine, alkali for the sodium hydroxide. You can see here sodium chloride plus water will be give sodium hydroxide plus Cl2 plus H2. Chlorine gas given out H the anode and hydrogen gas at the cathode. Bleaching powder. It is formed by the action of the chlorine gas on dry selected lime. You can select lime formula is what? CaOH2. It is formed by the action of chlorine gas on dry selected lime. Bleaching powder is represented by CaOCl2. It is represented by CaOCl2. You can see the uses of the bleaching powder for bleaching cotton and linen in the textile industry, for bleaching wood pulp in the paper factories, for bleaching washed clothes in laundry, and oxidizing agent in many chemical industry. These are the uses of the bleaching. So nowadays we are also using to protect us from the insects. We are spraying the bleaching at our environment. So bleaching cotton and linen in textile industry, for bleaching wood pulp in paper factories, for bleaching washed clothes and oxidizing element in chemical industry. Bleaching powder CaOCl2. Bleaching powder is also known as chloride of lime. It is a solid and yellowish white in color. Bleaching powder can be easily identified by the strong smell of chlorine. When a calcium hydroxide, that means selected lime, reacts with the chlorine, it gives calcium oxychloride and water. You can see the formula here. CaOH2 Cl2 gives rise CaOCl2 plus H2O. What is that one? CaOH2 gives rise CaOCl2 plus H2. So this is about the bleaching powder. Baking soda. It is produced using sodium chloride. The chemical name of the compound is sodium hydrogen carbonate. Sodium hydrogen carbonate, that means NaHCO3. How it is formed? It was formed NaCl plus H2O plus CO2 plus NH3 gives rise NH4Cl plus NaHCO3, where NaHCO3 is sodium hydrogen carbonate, which is called as baking soda. Uses. It is used in soda acid fire extinguisher. It also used as an ingredient in antacid for making baking powder. You can see here. Sodium chloride plus water CO2 NH3, NH4Cl plus NaHCO3. Next one is about the washing soda. The chemical name of the washing soda is Na2CO3 into 10 water molecule, that is 10 H2O. Recrystallization of sodium carbonate gives washing soda. It is a basic salt. What is the uses? Used in glass, soap and paper industries. Used in manufacture of sodium components such as borax. Used as cleaning agent for the domestic purpose. So here you can have the water of crystallization. What is water of crystallization? Many salts contain water molecules and are known as hydrated salts. What is that one? Many salts contain water molecules and are known as the hydrated salts. So the salts are having water molecules and they will be called as hydrated salts. The water molecule present in salt is known as water of crystallization. You can see what is water of crystallization. The water molecule present in salt is known as water of crystallization. For example, copper sulfate pentahydrate CuSO4 5H2O. Copper sulfate pentahydrate, which is in blue color. Blue color of copper sulfate is due to the presence of 5 water molecules. Why it is blue color? Because of 5 water molecules of water. 5 molecules of water. When copper sulfate is heated, what is that one? When copper sulfate is heated, it loses water molecules and turns into gray white color. Remember here, when copper sulfate is having 5 water molecules, it is in blue color. When it is heated, the water molecules are evaporated, then the copper sulfate is changed into gray white color. If you cool again, it will be get blue. Okay, that's other matter. Next, what about the plaster of Paris? You can see here, this is plaster of Paris we are using in our daily life and heating the gypsum. So here, what is gypsum again? You can see gypsum, we can see in the next slide. That is, on heating the gypsum at 373 Kelvin, it loses water molecules and becomes a calcium sulfate hemihydrate, that is CaSO4 1 by 2 means of water molecule. This is called as the plaster. CaSO4 into 1 by 2 H2O of water molecule, that is called a plaster of Paris. So here, and mixing with the water, again if you are mixing the plaster of Paris with the water, it will be called as the gypsum. What is the use of the plaster of Paris? So you can see figure. For making tiles, material for decoration, for making surface smooth, doctors use supporting fracture bones in the right position. Next, about the indicator. Indicators are the substances which indicate the acidic or basic nature of the solution by the color change. Example, litmus paper, turmeric, red cabbage, colored petals of some of the flowers like petunia, hydrogenia, and germania. Natural indicators. Methyl orange, phenolphthalein are the synthetic indicator. Substances whose order changes in the acidic or basic media. Such indicators are called the olfactory indicator, for example, vanilla and onion and clove. You can see there are many types of indicator, but I am talking about the natural indicator. Indicators obtained from the natural sources are called a natural indicator. Example, litmus paper, turmeric, red cabbage, China rose, etc. are some of the common natural indicators used widely to show the acidic and basic character of substances. What is litmus paper? Litmus paper is, I don't have time, that's why I'm going to quickly. Litmus paper is obtained from lichens. The solution of litmus is purple in color. Litmus paper comes into two colors. One is a blue and one is a red. An acid turns blue litmus paper into red. A base turns red litmus paper into blue. You can see here what is according to the litmus paper, what is acid, what is base. A litmus paper, which is in the blue color, if it is changed into red color, then this is in a solution. If you dip a blue color litmus, if the blue color litmus is changed to red color, then it will be defined as acid. In a red color solution, if you put the red litmus paper, the red litmus is changed into blue color, then it will be called as a base. You can see ABR, BRB. That is simple logic. You can use S into, that is A, B, R. Acid, that means blue color change into red color. If you take BRB for the base, red color change into blue. That's it. Turmeric. Turmeric is another natural indicator. Turmeric is yellow in color. Turmeric solution or paper turns reddish brown with the base. So here, with the base, the turmeric change into red color and it does not react with the acid. Means no change with the acid. Olfactory indicators. Substances which change their smell when mixed with the acid or base are known as the olfactory indicator. For example, onion, vanilla. Here, what is onion? Paste or juice of onion loses its smell when added. Olfactory means what? Regarding to odor, that means smell, not color. Paste or juice of onion loses its smell when it is added with the base. So when the onion juice or paste is added to base, that will be lose its smell, but when it is added to acid, it does not show anything. No, not lose. Next, vanilla. The smell of the vanilla vanishes with the base. If you are adding to, you might be saying ice cream. This is about vanilla ice cream. The smell of vanilla ice cream or vanilla vanishes, means reduces, vanishes with the base, but it smell does not vanish with the acid. Synthetic indicators. Indicators that are synthesized in the laboratory are known as the synthetic indicator. For example, phenolphthalein, methyl orange. Phenolphthalein is a colorless liquid. It remains colorless with the acid. Even though in acid it shows colorless, but it pink turns into pink with the base. So if you add the phenolphthalein to the acid, there is no change. But if you add the phenolphthalein to the base material, then it will be changed into pink color. Similarly, methyl orange. Methyl orange is originally orange in color. It turns into red with the acid. So the methyl orange, when it is react with the acid, change into red color. Similarly, when it is react with the base, change into yellow color. Then pH in our next one. pH in our digestive system. Dilute HCl, that means hydrochloric acid helps in digestion of proteins. Food proteins means the whatever things we are taking, whatever we are eating, that all will be considered proteins in our body. In our stomach, digestion of food in our stomach. Excess acid in stomach causes acidity. Excess acid in stomach causes acidity, that means indigestion. Antacid like magnesium hydroxide, also known as milk of magnesia, and sodium hydrogen carbonate, that is baking soda, are used to neutralize the excess of acid. That means you can people are nowadays preferring because these materials nowadays this is it is a risk to collect, because families are not they might be have okay they have the baking soda, but they are not able to store the magnesia of milk of magnesia. So that's why people are using red meat things, that is like the so here hydrochloric acid is excess in body. When hydrochloric acid is excess in stomach, it will be causes some acidity, that means pain in the body, and this will be reduced by using of antacid like magnesium hydroxide as well as baking soda. Tooth decay, this is a common problem to the every person. So here the bacteria present in our mouth converts the sugar into acid. The bacteria present in our mouth converts the sugar into acid. When the pH of acid formed in the mouth falls below 5.5 in the mouth, if the pH value is 5.5 below, the tooth decay starts. The tooth decaying start. The excess acid has to be removed by the cleaning the teeth with the good quality toothpaste. So what we need to do, we need to brush with a good quality toothpaste, because this kind of the toothpaste are alkaline or base. So we need to use base type of the toothpaste to avoid or to protect us from the tooth decay. Soil of the pH and plant growth. Most of the plants have a healthy growth when the soil has specific pH, that will be close to 7. So if the soil level pH, the soil of the pH, if it's close to 7, then the plants grow in a proper way. So if it is high or low, then it will be risky for the growth of the plants. Next, what is buffer solution? A buffer is a solution that resists the changes in pH when small amount of acid or bases are added. When a small amount of acid and bases added to the pH, and this will be resistor, means opposite, the change of opposes, and that will be called a buffer. A buffer is a solution that resists the change in pH when small amount of acid and bases are added. So little acid and base if adding means the solution not changing, the solution going to be resisting, and this type of the resisting, and which is for the pH by adding of small acid and base, is called as the buffer solution. Next one is about the acid rain. Pollution in the air of sulfur, pollution of the air. So pollution in the air. So why the pollutions occur? Because of sulfur dioxide, carbon dioxide, nitrogen dioxide combined with the water to form the various acid, and these are falling to the in the form of rain, and this will be called as the acid rain. You can see carbon dioxide with water, that is H2CO3. change in pH. What is happening? So the rapid changes in pH can be kill the fish and other organisms in lakes. Rapid changes in pH can kill fish and other organisms in lakes and streams. Soil pH is affected and can kill plants and create the sink also. So what is happening? If there is a change in the pH, the rapid change in pH can kill fish and other organisms in lake and streams. Soil pH is affected and can kill plants as well as create sinkholes. You can see the figures. So fishes and the roads are changed to be a sinkhole. So this is about the today's concept. Thank you.